Hello, this session is called Intro to TypeScript. My name is Noah Sager. I'm a product engineer on the ArcGIS API for JavaScript team. I'm joined today by Kelly Hutchins, who is a software developer, also on the ArcGIS API for JavaScript team. Kelly specializes in ArcGIS Online configurable apps. The presentation slides are already available on GitHub. You can find a link to it here on the screen. Let's get down to business. Here is our agenda. Since this is an intro session, we'll begin by explaining what TypeScript is and why you should consider using it. Then we'll see a real-life demonstration using TypeScript with the ArcGIS API for JavaScript, and end with some resources to help you in your development journey. What is TypeScript? TypeScript is an open-source programming language that is a superset of JavaScript. TypeScript builds on the successes of JavaScript while improving on its weaknesses. What we mean by superset is that JavaScript code is basically valid TypeScript code. You could almost rename your JavaScript files to TypeScript files and start using TypeScript today. TypeScript transpiles into JavaScript, which is really just a fancy way of saying that it compiles into JavaScript. The reason we call it transpiling is because TypeScript and JavaScript are at similar levels of abstraction or similarly distant from machine code. Where do I begin? The best place to start is with the TypeScript website. Here you can find lots of documentation and tutorials and really get your hands dirty with the language. Today, we're going to be focusing on using TypeScript with the ArcGIS API for JavaScript, but for TypeScript fundamentals, this site is a great place to start. If you're working with TypeScript and the ArcGIS API for JavaScript, the next place to go is this guide page. Here, you can find all the requirements for getting started, as well as code snippets and some tips and tricks to enhance the developer experience. Here's an example of a simple file structure for a TypeScript application. You have an index.html file, similar to standalone JavaScript applications, and you also have at least one .ts file, TS stands for TypeScript, a package.json file, and a tsconfig.json file. These JSON files will be important for configuring the application, which Kelly will demonstrate later. Let's look at some benefits of using TypeScript. At a high level, TypeScript is easier for multiple people to work on, easier to refactor, easier to test, can help prevent technical debt, and the reason we say these things about TypeScript is that if you're typing out interfaces, then you have a well-defined contract between different parts of your application. Then it's easier for another developer to jump in and understand what's going on. Lastly, TypeScript is compatible with every flavor of existing JavaScript. So let's talk about why to use TypeScript. TypeScript adds type support to JavaScript. While JavaScript is a loosely typed language, TypeScript can be a strongly typed language. I say can because this can be configured or modified in those JSON files I was talking about earlier. In this code snippet, we see a function that takes two parameters, a URL parameter and a legend parameter. Notice the colon after those parameters. The URL is of type string, and the legend enabled is of type Boolean. This makes it very easy to use these variables, both for current developers and for anyone who might review or modify the code in the future. Down at the bottom, we see the appropriate types of values being passed to that function. Another benefit is enhanced IDE support. So this is a similar code snippet here, but this time we assigned the URL parameter to have a value of type int instead of type string. Here, I'm using Visual Studio Code, and I see that it gives me an error at the bottom where I try to pass a variable of an incorrect type to that function. So before I had a string in the URL variable, and now I have an int, 1, 2, 3, 4, 5. Fortunately, the IDE gives us a meaningful error message and tells us what the issue is. This helps prevent errors even while you're still writing your code, and will save you time when you get ready to actually test the app in the wild. Another reason to use TypeScript is it makes use of the latest JavaScript features. On the left here, we have a demo theater function, which calls a getQuestion function. The getQuestion function returns a promise, which, once resolved, calls another function called question. Now on the right, we have those same functions, but this time we've made use of async-await functions. Since we make the demo theater function an async function, we can use the await method in the getQuestion function to wait until the promise is resolved. The functionality is the same as on the left, but with fewer lines of code. Another cool thing is called dynamic imports, or lazy loading, which is cool because it has the word lazy right in it. This means that you can have a module that doesn't get required until you actually need it. In this code snippet, we see an async function that imports a module when it's called. So if the function never gets called, then we don't import the module, and this can save us time and resources. Now, for getting started, the recommended way to install TypeScript is via Node and NPM. If you've worked with other frameworks, you should be familiar with these tools already. We also recommend that you install TypeScript globally, and we have the code snippet on the screen. And we also recommend installing the ArcGIS API for JavaScript typings. Now, one cool thing about these typings is they can be helpful even if you don't use TypeScript. So highly recommend that you check these out. But enough talk. Let's go ahead and hand it off to Kelly, and let's see a real-life demonstration of using TypeScript.
Thanks, Noah. Now we're going to go through the process of taking a JavaScript sample from the SDK and converting it to TypeScript. So here's the sample. The sample is called Bookmarks widget. It has the Bookmarks widget from the API inside of it. This just has a bunch of pre-saved extents that you can use to navigate through your project. So we're going to take the code that's available here and bring it into a Visual Studio Code project and convert it. It doesn't have to be Visual Studio Code, but I've found that when you're working with TypeScript, VS Code is great. It gives you a lot of nice TypeScript integrations, and it makes your life a little bit easier. So let's take a look at this project we have set up. I just created the project, and I copied over the content from the sample and the help into this project. So I have an index.html file. It's set up to find the JavaScript file in the current location path, which I've defined here, pointing in the source folder. So that's currently where our JavaScript file is. And then we load that JavaScript file when the app starts. So that's our index.html. We also have a styles folder that has the CSS that we copied over from the sample, and this JavaScript file, which has the JavaScript that we canceled over, or that we copied over. That's it. Our project is set up. We have a few additional things like a package.json file where we could install any dependencies that this project will use. The only dependencies we have right now are the JavaScript API types and live server. Live server is this simple, lightweight server that we can use to run our code and watch the changes. So that's helpful. When I installed that live server, I also set up a script. This script is just a shortcut to executing that live server command. So I can start up that live server. It's going to look for an index.html file in that current location of this package.json. So it's going to find this index.html file and spin it up on its own server. So we can run it from here, or in VS Code, there's this npm script section where we can run it from here. So if we look at that, we can see that here we have that same sample. It's running in our Visual Studio Code project, so the bookmark sample. Everything's working. It's just JavaScript code at this point, moved into Visual Studio Code project. Now we get some benefits out of the box from this in Visual Studio Code. So we can see that we get things like code assist, so we can see the properties that are available to us and methods that are available to us in the JavaScript API. So that's all really nice features, is the code assist is helpful. we also would get notified about unreachable code or labels. You could set some TypeScript configuration options to let it notify you if you have functions that are supposed to return that don't have a return at the end of the function, or if you have like a switch statement that doesn't have a fallback, you could set up warnings to notify of that. So you'd get some benefits just by setting it up in this project with the TypeScript configuration. But we're going to go ahead and convert this to TypeScript because that's what we're here for. So here's this tsconfig.json file that we add to our project that tells the TypeScript compiler what we want to do and how we want to handle our files. So we have a really simple one here. This simple one has a few things that I'll explain. The first is this output directory. So we have our JavaScript file here, but when I convert this to a TypeScript file, it's going to spit out the TypeScript compilation will happen and it will generate this JavaScript file for us. When we have that set up, I want to send it to this built folder. You don't have to have an out directory. You can specify that it goes in the same location as the TypeScript file, and that's fine. But in this project, we're telling it to go to this built location. We have this allow.js flag set to true. So this lets us have JavaScript files in our application without complaining. We have the target. We can set the target to various target versions. So you could set it to ES5, which is what we'll start with. And this will transpile that JavaScript back to, or that TypeScript, sorry, back to JavaScript that supports ES5. So if you're working with older browsers, you could do this so that any new constructs that aren't available in those browsers will be removed and extra code is added to support that in those browsers. And we'll see an example of that. And then we have this include, which tells us which files to include in the transpilation. So we basically want anything that's in this source file. So it's a really simple tsconfig file, and we'll come back and look at that more later. So now what we're going to do is start the conversion of this. So first, let's run our TypeScript compiler, and we can do that by using this command tsc. And if we add -w after it, we're going to start watching all of our TypeScript files and running them through the TypeScript transpiler. So in this case, you can see that when I turn on tsc watch, in this built folder, this main.js file appeared. It's pretty much at this point exactly the same as the one in the source, but it went through the TypeScript compiler and made various adjustments depending on your settings to this file. But now let's close this back up. Now let's just rename this extension to TypeScript. And you can see that right now we have a TypeScript file. Our project would still run, but it found a bunch of errors in the project as soon as we changed the extension to TypeScript. We could still run our app. Our app will still run. It's just kind of complaining about a few things. It's saying that all of these things have this implicit any type. It's a little bit weird, but basically, you know, these things all would have to be typed so that TypeScript can understand it. And right now, TypeScript doesn't understand any of this. So the first thing that we want to do in our project is change this require over to the import statement so that we can get it set up and TypeScript will stop complaining about these implicit any's. So let's find the end of this here. We can get rid of this and we can comment this out for now. And we're just going to move these over to import statements. Okay, the TypeScript does understand. So we'll start with import webmap from Esri webmap. Let's see, I probably should code. So we can see that we get pathing support here so I can choose the right options to help me prevent making typos like I just did. Then we'll import map view from Esri views map view. Then we'll import bookmarks from Esri widgets bookmarks. And then our last one, import expand from Esri widgets expand. Okay, so now let's get rid of this comment because we've imported everything that we need in our project. And now if we save it, we can see that we don't have any errors. Congratulations, we now are running a TypeScript file. So now if we look at our finished project, let's see. Okay, so now it's not running, but what did we do wrong? It was running, I converted it to TypeScript. What is going wrong? So what's going wrong is that it's looking in this source folder for a main.js file. But if we go back to our project, we can see that in our source folder, we now have a main.ts file, and that JavaScript file is in that output folder, that built folder. So I need to go back to index.html and change this to built, save, and now we can see that everything's working. We've converted our TypeScript to our JavaScript application. So let's just recap what we did. All we did was copy the code over, set up a tsconfig file, and then changed our extension from main.js to main.ts, and then switched out that require to these import statements. And now we have a TypeScript project that's up and running. But let's not be finished here. Let's play around and make a few more changes. One of the things that we can do is take advantage of some of the ES6 and TypeScript capabilities. So let's look at a few of those. One of the things that I really like is this concept called object property shorthand. So if we have this variable named map and this map view constructor has a property named map, currently we say map:map. Well, we don't have to do that. We can just use this variable name, and it understands that this property name map will use the value from this variable map. So we have another one here, view, we can get rid of. Another one here, view, we can get rid of. So it's not a huge deal, it's just nice and it saves us some typing. Another thing that I really like is this optional chaining. So in our JavaScript app, they want to check and see if the map actually has bookmarks. If it has bookmarks, they want to display this particular message in the console about there are 8 bookmarks or 7 or however many there are. If there aren't any bookmarks, they want to display another error. So this code's fine. They say if map.bookmarks, and so if this bookmarks property exists, and if it's got a length, then execute this console statement. But what we can do in TypeScript is use these conditional checks. So we can shorten that to this, and that will check if this map object has a bookmarks property, then evaluate it to length. So it's all just conditionally checking. So we don't have to say if map.bookmarks map.bookmarks.length. We can shorten it to this one sentence. So this is really nice, a nice feature that we can take advantage of. Another thing we could do is we could use template literals to build this sentence. This is especially useful if you're concatenating strings, so if you're combining a bunch of string information together. So let's see how that would work. So if we want to define a message equals, and then we use the backtick. So this is the thing that lets us know that we're working with conditional or template literals, sorry. So we can say bookmarks, colon, space, and then we can use map.bookmarks.length. So we're constructing it all as one. Inside these backtick marks, it's all one stream. We don't have to concatenate anything, and we are up and running. So this is a nice way of building strings and combining a bunch of values. I use this all the time. So now let's run our app and see if it still works. Still works. We still get our bookmark message. We can reload just to show you that everything's still running. Code still works. We still get that bookmarks message. Now let's go back at our code and look at a few more things. Remember how I said in the TS config that you could set the target, and that target determines what that output JavaScript looks like. So we're saying that we want to support ES5. So if we look at our JavaScript file, we can look at it and see that even though our TypeScript was using that object property shorthand, ES5 JavaScript doesn't understand that. So the TypeScript transpilation process knows that it has to make modifications. It is spitting out to an AMD module, so it knows it needs to put these require and define back in. It knows it needs to set the object shorthand to take it away and include both view and view. It knows that can't use template literals, so it goes back to bookmarks plus map.bookmarks.length instead of that template literal string. And then it can't use the the conditional operand, so it adds all this extra logic in here. So what happens if we change that target to like ES 2019, which is more modern browsers that support many of those constructs? So let's save it. And let's go back and look at that JavaScript file. Let's see. Okay. Now, if we look at it, we can see that it did not have to take away the object property shorthand, and it's able to use the template literal. So this is the benefit, is that it's a little bit less code that's required that the transpiler potentially has to add into your JavaScript to support older browsers. So if you know you're only working with more modern browsers, you can use a different target like 2019 or 2020 potentially. But you can read up on all of these different ECMAScript target versions in the TypeScript documentation. A lot of really good information there. So that's it. That's the basics, is converting your JavaScript project to TypeScript. It's pretty simple. You set up the TS config, you copy over your JavaScript, rename it, and then make any necessary changes. Some projects will be more complicated, and after you update these import statements, you might have a whole bunch more squiggly lines in here, and those are issues that you'll need to fix in your project. So if you do that, the easiest way that I found is you hover over, so like if we're missing some value, you'll get this squiggly line. You hover over it and it tells you what the problem is. So then you can Google that particular issue and try and find the solution to fixing that problem. So good luck converting your projects. I hope you enjoy it, and thanks for attending the session.
Wow. Thanks, Kelly. That was really awesome. So to review, today we told you what TypeScript is, why you should consider using TypeScript, and how to actually build your first TypeScript app using the ArcGIS API for JavaScript. But before you go, we'd like to share with you a few more pieces of information. The first is where you can get more info. So the SDK documentation is a great place to start. We also have several other Esri-related trainings and webinars about using TypeScript with the JS API. And we have blogs, and there's of course GeoNet and Stack Exchange are also great places to find more information. So with that, we'd like to thank you for attending this session. And if you're interested in using TypeScript more, we have a more advanced session available called Using TypeScript with the ArcGIS API for JavaScript. And you should be able to search in the Dev Summit agenda and find that session. Then we'd like to say thank you, And if you're inclined to leave feedback, we would greatly appreciate it. Just go ahead and click below on the survey link, and you can let us know how we did. Thank you very much.